Thanks, Maria, and welcome, Gernot. I'll give you some of the nuts and bolts background on Gernot really quick, and then I'll tell you how we're connected. Dr. Gernot Paulus holds a PhD from the University of Salzburg in Austria and has been appointed professor for Geoinformation at the Department of Geoinformation and Environmental Technologies at Carinthia University of Applied Sciences in Villach, Austria since 2002. He's been awarded a Fulbright research grant to go to San Diego State University in 2014 and has been an adjunct faculty member in their department since then. And since 2019, he's been leading the interdisciplinary research group Sienna, Spatial Informatics for Environmental Applications at the Carinthia University of Applied Sciences. Some of you on the call already know Gernot well, and that's because him and I know each other for the same reason you do, which is that he's been involved with San Diego State University and some of the faculty there for a number of years. And now I'm very happy that in my time at UNM, we've been able to send students back and forth from CUIS to here and vice versa. And several of you have been there and worked with Gernot already. And we're continuing that collaboration on a number of fronts. And so it's a real personal pleasure of mine to be able to welcome Gernot to talk about his work. So please join me in giving him a warm welcome, and thank you, Gernot, for extending yourself to be here at this hour.
Okay, yeah, Chris, Maria, dear colleagues, thank you very much for this really very warm welcome. That late here actually in Austria, so I will do my best not to fall asleep, but yeah, I'm very happy actually to present to you a very unique project in the context of art, GIScience, soccer, and geography. We performed in 2019 and 2020, and this project actually, on the one hand, really received worldwide attention in the art world, having a forest in the soccer stadium. But actually, this art project also triggered and created quite some unique challenges and also opportunities for science in our field, in the area of surveying, forestry, digital transformation, and also bring this type of data into virtual environment. And this actually I would like to talk about today. But before we go here into the detail of this project, just maybe please allow me to take some look back as at the starting points of our collaboration. So this is here my colleague Charlie Anders, and this is actually the starting point of our research activities in the area in the context of using drones for high resolution data capture. This was in a training course at San Diego in 2011, and at that time, actually Chris Lippitt and Grant Fraley started here their business with TerraPan Labs, and this was actually also our first investment. What you can see here in the Lewis platform, and actually from there we continued our collaboration, and I put here a little bit of the things together. Chris has already mentioned some of these activities. It's sort of a little bit of a magic triangle actually. So between UNN, SDSU, and also our university here in Austria, and this is actually thanks to the Austrian Marshallplan Foundation. So the Austrian Marshallplan Foundation is actually supporting transnational research projects between students in the United States and Austria. And as you can see here, we have been quite successful in this area, starting here with Andrew Lurch in 2016, who came to CUIS, Jesse Sprague, and also Daniel Bean. Then we had from our university Thomas Schneider, Mohammed Sadoun, and also then in this spring, one of our students, Lucas Schaffhauser, will come, and then we also had Blair in 2019 also at her time when she was at SDSU. And then it's also this interesting linkage that Andrew then moved for his PhD to SDSU. Blair is now in New Mexico. So a lot of very interesting connection points here. And just let me share maybe some of the images here. So Daniel together at the Marshall Plan Award ceremony here with the US ambassador in Austria, or together here during a visit at the campus in 2019 with Thomas Schneider and Blair, actually here on a joint hiking trip in the Slovenian Alps together with Professor Jankowski from San Diego State. So a lot of connections and collaborations which actually started a long time ago, and also we have tightened over the years. So maybe just some words also about our background and our department here. So I'm from the Department of Geoinformation and Environmental Technology at Carinthia University of Applied Science. You can see here the campus. We are a pretty small university with 4 campuses in Carinthia. A very beautiful location in the very south of Austria, close to the border to Italy and Slovenia. This is one of the premier tourist destinations here in Austria. And we started in 2000, in 2020, our 20 years anniversary. Have here a bachelor in information technology with geoinformation and environment, and also successful international master program, spatial information management. And then also starting already back in 2019, we have really focused here on applied drone research. And I'm leading this research group, Siena, trying to get information out of these, let's say, high resolution drone images for environmental applications. And so we are also working on different types of projects. I've just put a short selection here. On the one hand, we have new European regulations, and there we have developed here a web portal to automatically do an analysis of the risk assessment for a drone mission. We are also part of a national consortium, Air Labs Austria, to set up here a structure and also the operation of a national US test site infrastructure here in Austria, or another also very interesting project where we also used drones and videos and optical measurements to detect here surface velocity fields in the context of trying to understand flow patterns around fish passages at hydropower dams. And then in 2019, we had the opportunity also here to start this project for forest. And I would just like to give you a little bit of a background and start with the artistic perspective. So this project, Trees in a Soccer Stadium, represented actually the largest art intervention in public space in Austria, and was organized and managed by Klaus Lippmann, who's a Swiss artist. At the starting point, and it started in September 9th and ran till October 2007. And the idea of this project got back to this painting. So this is a painting of an Austrian artist, Max Beintner, and this is from the 1970s, a pencil drawing with the title, The Unending Attraction of Nature. And at that time in Europe, we had severe environmental problems due to acid rain, so a lot of threats to our forests. And he actually imagined the threats of a forest maybe in the future being only visible and like an exhibition. So this was the starting point. And actually at the time when this project started, also we had to face also tremendous catastrophic fire events worldwide, starting from Australia, in Amazonia, and also as the US. As you all know, So also from this point of view, this project received a lot of attention. So actually, here you can see Klaus Littmann and the first impressions. We have here in Klagenfurt a very fancy soccer stadium. This was built for the European Soccer Championships in 2008. But unfortunately, we didn't have at the time when the project was planned here also any soccer club playing in the National League. So this was also the reason why this stadium was available for this art project. And as you can see here, this caused a lot of attention, and this was also very, very special impression. So it started in September 2019, and here I would just like to share with you some of the views. It was really spectacular. This a forest of almost 300 trees representing 16 different species, so a sort of a European mixed forest. Here you also can see the stadium. The exhibition actually was open from 10 a.m. till 10 p.m. We had actually free access. So in the stadium, normally there are about 30,000 visitors are available or are possible to or can attend here, and then also over these almost little 1.5 months, you had also changing of the trees, so people also really went in for different times, and almost 200,000 people attended this exhibition. And also it received a lot of media coverage in over 80 countries worldwide. So it was a project which will maybe not happen again like this. And this was also for us then actually just to shift now a little bit from art to the scientific perspective. And very, very interesting opportunity. So actually this forest in a stadium can really be seen as a sort of really a worldwide unique experimental science lab. We really have controlled conditions for asking or investigating questions in the context of forestry, surveying, digital transformation. So the questions actually we put together here, we were interested in is, on the one hand, of course, this overall handling of huge amounts of digital data representing here the real world, and then also there are different types of sensors available, and actually how can we fuse these data products coming out of the different sensors, in this case here a terrestrial laser scanner and very high resolution photogrammetric results from aerial drone imagery. Then a very important question also is then how real and with which accuracy actually you can represent green space in 3D environments. And the last question was also, on the one hand, you have this art intervention, which is very unique, which is temporary, which will not last, or which is only available for a very short period of time. And how can we document, preserve, and maybe also make this available for experience for other people in virtual environments. So these were the core questions we were interested when starting this project. So actually, I would just like to start here now with the different views on the data capture. And the first one is the vertical view. Here we performed drone missions and also did photogrammetric processing. So here you can again see the stadium with the mission plan. Here in the stadium, you can see how it does look like if there are no trees in the stadium. So you can see that it makes quite a difference. Here are some impressions also on our OS we used here, and just give you here a brief summary of the missions here we performed. This was a multi-rotor system, like an iPod AX20 with a full-frame Sony A7 camera. We performed quite a high overlap with quite low flight altitude of 70 meters with native view, and also did a cross-grid mission plan. So in total, we had about close to 600 images, and also very high resolution in sub-centimeter. And we also had about 10 control points in the stadium available. We also used them for validation, and also we received here a very good positional accuracy of the data, and the photogrammetric processing was then done in Agisoft photoscan. So quite a straightforward standard approach. So here are some of the results of the auto photos here. You can see the forest with the clearing in the middle. The forest was not accessible for the visitors, so the visitors were only allowed here to move around in the stadium, but not having access to the forest. We also had here some artifacts at the roof due to sun reflection, but also as you can see here, the results of and the quality of the auto photos were really very nice. So, and then also we ended up here with the photogrammetric point cloud here, and what you can see here consisted out of about 800 billion individual points, and this was actually one of the data sets we actually used then further on in the project. So then just to change the perspective a little bit now from the vertical to the horizontal view, we also took the chance here to get access by an excellent cooperation we have here with GIScience Austria, to also use here laser scanning to get also data from the ground. And also what we did, we collected reference data. So what you can see here is a terrestrial laser scanning system from Leica, so a 3D laser scanner, the RTC 360, and we actually use this to capture the whole area on the ground, outside of the stadium and also inside of the stadium. Here are some technical details. So we used two of these laser scanner. They are really very high performing, so actually able to capture about 200 million points a second, and they are also equipped with a high resolution imaging system. So just one 360-degree scan, and also the image capture takes a little bit less than 2 minutes. We had for the terrestrial laser scanning actually 4 days available. We started at the beginning just to capture all the outside of the stadium, and then we only had 2 days to get access inside the stadium. And this was just a very, very short and ambitious time window, because they were just in the preparation of opening everything. And this was at the 6th of February, where the international media and the press conference actually took place. And you can imagine that we didn't receive here the highest priority just running around and taking some measurements in the stadium. And also then, in order to combine the different data, we use the total station and about 30 black and white targets here. Also then to link and integrate the different point clouds captured here. So in total, we really have a very dense set of measurement points here of about 577 individual positions distributed in the stadium at different levels, and also outside the stadium. So from here also an excellent data set. You normally it's very hard to get this type of high resolution data set in terms of accessibility in different types of forests. So this was really an excellent and unique opportunity for us. What we also did is that we took some reference data. Here you can see some of our students. So they have, all of them actually are Geoinformation students, but have a forestry background. So they helped us in mapping all the different types of species. And what we also did is then the measurements like the breast height, diameter for all the trees in the forest. And what you can see here now is the complete 3D terrestrial laser scan point cloud. What you can see here, this is the result of these 4 days of measurements. So a lot of the environment outside of the stadium and also the whole infrastructure inside the stadium. We also have here a collaboration with the Department of Surveying and Geoinformation of the city of Klagenfurt. And they are also interested not only in the forest itself, but also capturing the whole infrastructure of the stadium. So the next step was then related to how can we actually bring these different types of sensor data together. So on the one hand, we have the photogrammetric 3D point cloud, and on the other hand, the terrestrial laser scanning point cloud. And here I would just like to go and show you a little bit of the validation results. So here we decided to compare selected detailed views. On the one hand, we had a stair in the stadium. What you can see in the middle is the clearing in the middle of the forest. On the right hand side, one tree we selected. And in the next view, you can see here then the different types and contributions of the point clouds. In red, these are the point clouds provided by the terrestrial laser scanner, and in green, these are the point clouds derived from the US. So you can see here specifically with the stairs that a lot of the data and information is coming here from the terrestrial laser scanner. And on the tree on the right hand side, you can also see quite nicely in green actually the contribution for the top of the canopy here coming here from the drone. And this was also the idea we were interested in actually how what is the additional amount of information we can get by combining these different types of sensors. And in the lower part of the canopy closer to the ground, where we also do not get that much sights from the imagery here, we have definitely get more information out of the terrestrial laser scanner. When we also were combining or comparing the different types of point clouds, and here we use Cloud Compare to calculate the difference between the point clouds coming from the terrestrial laser scanner on the one hand and from the photogrammetric processing of the US. You can see that actually they fit quite nicely together. So here you can see on the right hand side here with the histogram. So in blue, actually the difference of the point clouds for the clearing, and also the same for the tree, at least in the top of the canopy, is in the area of about 3 centimeter. So this is actually the 3D point cloud difference for these two examples, and this is actually a quite nice result. But you can also see here in the trees that because we do not have here a lot of information from the UAS point cloud in the lower parts for the canopy of the tree, therefore we also cannot compare it. But also here on top of the canopy here, again, this really fits together quite nicely. So also then what we also checked here is then the quality and the registration accuracy of the two different point clouds. So what you can see here is then actually the final result. This is in total about 27 billion individual points here, bringing those two point cloud data together. And we also had here about 10 contour points located in the stadium, which were actually visible for the drone, and also in the terrestrial laser scan data, and also here the positional or the horizontal accuracy and also the vertical accuracy by combining the different point clouds together of the final result is also in the sub centimeter range, and this is also a very excellent result. So now we have the point cloud and the data together, and then this is of course a great data set, and we started then to provide this data also for our students to work on their bachelor thesis. We also integrate this data set here in our different teaching activities. So some of the examples and maybe the results here I would like to show you is, on the one hand, on the left hand side you can see the build-up plan. So there was a Swiss landscape architect, Enzo Enea. He was actually responsible in designing all the different types of trees and arranging those type of trees here. So what you can see here on the right hand side is then the revision plan, and actually the build-up plan and the revision plan, there are quite huge differences, and these differences just came up during the build-up of the forest itself here. So for various reasons here, they had to rearrange, and this is now at the official revision plan, where we have different types of species, and the squares are representing the coniferous trees here, and the circles, the deciduous trees. And for all these trees here, actually also we have a database then developed and set up, having all the data about the species, breast height, diameter, and so on. Then this is also then a great data set just to do exercises like developing here the canopy height model, working with the surface model and the terrain model. We also experimented here with some algorithms in order to detect single trees, and this also worked out quite nicely with a high detection accuracy. Here the issue is that not every tree here, or sometimes has multiple crowns here, and how you decide then, even in the field here, is this one tree or is this representing more trees? This is this example of the single tree detection, and then we also just performed some supervised classification on the orthophoto in combination with the DSM in order to separate here the the ground and the vegetation, and also classify the individual trees by supervised classification. And the last comparison here we started is the validation of the breast height diameter data. So this is the diameter taken at about 1.5 meter above ground here, and also the differences here are actually ranging from relative what you can see here for these selected examples here between 4% up to 18% here. So these are some of the first results we actually gained out of these data sets, and we actually come now to the last part, and here actually the circle closes a little bit again at the end. So it started with an art project, and the project ended here also at an art festival. So we received an invitation to present this project at the Ars Electronica Festival last year in September, almost 1 year later when we started this project. Ars Electronica is also a very famous festival in Austria, in Linz, and has the focus on electronic art, technology, and society. And here they actually have a very unique visualization facility. That's an 8K visualization room. So this is very, very impressive. They use this room for different types of science projects. Medicine students are taking anatomy classes in there. And the idea was actually, is it possible just to take our data set, this integrated point cloud, and bring it into this 8K visualization environment, this so-called deep space. This was, of course, related then to a lot of challenges, because there is actually the bottleneck is that on the one hand we have 27 billion points on the one hand, and the system is just able to handle about a little bit more than 1 million points here. So in order to integrate, to bring in the point cloud data here then into this deep space environment, it also took some sort of filtering process. And at the end, it was actually then successful, and we managed. And these are some of the impressions here from this presentation in September 2019, and it was actually very, very interesting. Also for the artist itself, because he actually couldn't imagine how this 3D representation of his art project actually looked like. And you need here these 3D classes, and I cannot show you here now the full experience, but just some impressions. And it was really, really interesting. So we actually programmed some flights over the stadium, and then the really interesting part was it was also then possible here to interact and really walk into the forest and just experience this art project in a completely different way. So it was possible here for the visitors here actually to access the forest here during the art project itself in the stadium, but suddenly in the virtual world, in this virtual representation, actually this was then possible, and also raises a lot of interesting questions in order how to utilize this type of visualization environment in order also to have more efficient algorithms available in order to really get here then also, let's say, better visualizations at the end of the day. So this was also really for us a very interesting experience and opportunity, also to present data in a way we didn't have the chance to do so before. So I'm actually now close to the end. What you can see here is the team, the colleagues from the Department of Surveying of the city of Klagenfurt. Here, our drone pilot colleagues here from Leica Geosystems, and yes. So here you can also some of the acknowledgements, of course. Klaus Littmann, who allowed us here and supported us in order to perform all the data capture. And this was actually just sort of a fun project, so we didn't receive any funding for this. So this was just actually hobby work during the holidays. But it was really very great experience, and also thanks to the support for the laser scanning from Leica Geosystems, and also the colleagues from the Department of Surveying and Geoinformation of Klagenfurt, who did all the reference measurements on the ground. And so that's it from my side, and I'm very happy here to take questions. Thank you.
Yeah, thank you, Gernot, for that really interesting project. I'm sure there's going to be a lot of questions here, so I will moderate them. Let's see, we've got a couple here in the chat already. So Eric McGrain from NMSU says, what a fabulous project and talk. Thanks. I'm curious if you can speak more about any interactions that you had with Littmann and or his team, maybe in the Deep Space 8 takeoff piece. How would you characterize the relationship between an artistic and scientific approach epistemologically in the context of collaboration? Also, on another topic, can you speak at all about the political response to the installation in the stadium?
Yes. So this was for us. This was very interesting, because in our first meeting with Mr. Littmann, he actually was not sure if he would like to preserve his piece of art for later generations at all. You know, this is something, and so we were actually coming with our, fancy tech approach. Wow, we have great sensors, and we have drones, and we can make this all digital. And he didn't actually did not reflect to our enthusiasm at the beginning. But actually, then when we managed at the end of the day really to bring this into this deep space environment, this also offered a completely new perspective also from him. So he was actually very, I think he liked it a lot at the end of the day, because also this opportunity, for example, to have access to walk into the forest, you also can interact what you actually are not able to do so due to many security reasons, and so on. And this has, of course, a lot of potential also then for future exhibitions about the project. So he is actually also planning exhibitions. He had some invitations also to present this work in Australia, also in Germany and in Basel. And there are also discussions how actually we can support and integrate this type of virtual information here now into an exhibition. Of course, for the younger generations here, I think it's a very interesting new point of view, and opens, I think, a lot of opportunities. The political aspect was also very interesting. what you can imagine that it is a project which caused a lot of disturbance somehow. I mean, we are in Austria quite lucky in terms of having here you know, a lot of clean environment and trees available. And then why do you want to plant a tree into a soccer stadium? And then unfortunately, it was actually really a very unfortunate situation, because exactly at the time when the exhibition started, we had another soccer club in Carinthia who qualified very unexpectedly for the European Champions qualifier. So we have now, for the very first time since many times since a very long time in Carinthia, a successful soccer club, and it's not able now to play against other major European soccer clubs in the stadium because there are trees in the stadium. And then yeah, there was a lot of discussion about this, and then the project itself was also actually funded by private sponsors. So the city of Klagenfurt provided the stadium, but I think no public tax money actually was also spent. So it was all privately funded, and I think it was, yeah, very interesting.
So Brad Hansen wants to know more about why people weren't allowed to interact with the forest, but he also wants to dispute whether it can actually be called a forest or whether it's really more of a park, given the size, ephemerality, and heavy-handed regulation of human interaction. Brad, you can expand on that if you like.
I'm just curious, yeah, like what the response is from that, and maybe I can respond as the doctor's response.
Okay, yeah, of course, that's a good point here. So what actually this Enzo Enea and this team from the landscape architects did, they actually tried to do or let's say to make it as close to a forest as possible. So they once they had you had to bring in the trees with the big trucks and just then put it there, and then also they put in some lower bushes and everything. They also placed some logs of deadlock in there. In the forest, so that you also have a little bit of the different, let's say, structure, or an approach to get also the structure of a forest there. They also did actually a mix of a European forest we do not have actually at the moment, with these different types of species in the area. And then they also planted the lawn at the border, and it's a, well, yeah, it's a park, or it's a small forest, small piece of forest, and the interaction that people were not allowed to access. This was just for security reasons. Because you know, if people maybe start climbing on trees and something is happening here, this might have been simply too dangerous and maybe not covered by insurance. So these were just safety reasons here. But what they did, this was also interesting. So they had some theater performance in the forest. And also some concerts, and people really came and stayed, and they came different times here, and they also had some sort of changing of the colors of the leaves here from early September till late October, and I think almost about 200,000 people or visitors actually came.
Awesome. Thank you for sharing all that. Yeah, that's, man, I understand the insurance thing. That's a bummer because climbing on trees is like some of the best parts, right? Were like, did any bird folks like come in, or like were there any kind of like animal, or was it just trees?
No, it was just trees. So they did not put any animals in there. I mean, of course, there are the jokes, of the hunters. So whatever, been nice opportunity here to have some deer in there. No, but what they saw is that different types of birds came in. But I think there has not been any scientific project in that context also to see how the closer species might react to this new opportunity.
Thank you.
So here's a question from Craig Allen, who of course is one of the world's preeminent forest ecologists. And he asked whether you can imagine implementing this kind of 3D virtual data collection on a similarly sized natural or wild forest stand of global significance, where you could then use the virtual forest for virtual visitor experiences and education, archival baseline data, and just as scientific data on that forest.
Well, I think I would not expect it to use here drone technology. So from the view above, you just maybe need some sort where you can actually safely start and land, and maybe also be able to perform flights beyond visual line of sight. It depends a little bit, of course, on the plot. I think it will also work with the terrestrial laser scanner on the ground. You just will need, I think, again, quite a lot of positioning, and then it's always the question on the also on the accessibility. So I mean, here we had excellent conditions. You can actually walk around the complete piece of forest and view at different angles, and this might depend a little bit on the selection of the site. But if this is accessible, then it definitely should work. And then, of course, you also have now, maybe if you have the opportunity, also additionally maybe to use laser scanner from the air, either maybe from a plane or even also from a drone. And if this is a laser scanner on the drone, which is also able to do multiple responses, because then you also can get different levels of the canopy. So depending also how dense the canopy will be, but of course I think this should be definitely possible and a very interesting project.
Craig,
I would just
follow-up?
yeah, just if I could comment on it, that I mean, it's very cool and something some of us have sort of dreamed about for a long time. And yeah, we know in a general sense you can do this, but the super high resolution and quality that you demonstrate here could be really important for conserving the information value as well as the aesthetic value of forests that are going to disappear this century, likely in the trends we're on climate-wise. These are irreplaceable, forests that are centuries to thousands of years old in some cases. And the higher quality of the record that can be collected now will be part of what is conserved moving forward in time. And so I could imagine there could be literally a market for this at some point in time. I mean, this is obvious, probably would have been pretty expensive if you had to like pay for what you did, but maybe it wouldn't take 27 billion points. Maybe it could be done with, I don't know, a third of that number of intensity of points, but this could be a really valuable thing. And from a global conservation standpoint, as well as public outreach and information. So,
yeah, I think also, definitely. And what was for us also really very interesting, and we're really very happy also in order to achieve such a good actually a currency in order to bring the different types of sensor data together. And if you then, for example, perform such a mission some time later, maybe whatever might be interested, maybe some years, and you also be able to achieve the same accuracy, then it will really get interesting, because then you really can start to calculate just the change in different types of variations, and really document and quantify. But here I think it's also very, very important to have a very close collaboration here with the domain experts in the field, just to know what you're interested in, because if you're, I mean, we are trying always to shoot with the highest resolution because it's just cool, but it doesn't maybe not always make sense, and it's
Right.
needed, but so yeah.
Well, I could connect you up to the right people. The example I used particularly was like giant forest in Sequoia National Park, and colleagues there for 30 years have large hectare-sized plots that would be sort of equivalent to the scale of what you did. And they've been measuring intensely on the ground, and have been trying to do some ground-based laser surveying, but they have long-term baseline measurements, and these forests are changing rapidly. And so, as you say, this would provide a baseline of high resolution of three-dimensional point clouds that could be repeated and would be combined with all the other things that people are doing to really tell a story of how dynamic these forests are and how they're changing, in at least particular parts of the landscape. So anyway, thank you.
Thank you.
I'm gonna skip ahead to a question here from Doug Stowe, asking about how long did it take to plant the forest in the stadium, and how long will it remain?
Well, the second part of the forest is not there anymore. So it and it was actually a very challenging and ambitious project. So in the stadium, I think at 5th of August, they had a big concert with about 20,000 visitors. And just after this concert, they started to bringing in all the trees. So the trees have been brought to Klagenfurt before, and then they had almost 1 month to get everything ready. So this was really a lot of pressure. And then they had the official press conference on September 6th and the official opening on September 9th. So they had really, it was actually 1 month to plant 300 trees in the stadium. And then the exhibition ended on October 27th. And then they had, I think, about 1 month also to remove all the trees. And the trees are now, I think, on another site in Austria. So it was a little bit difficult here to find a home for this forest as it was in Carinthia to several reasons. But this was, yeah, it was really a temporary project of maybe about 4 months in total.
Okay, I'm going to come back, Chris, to your question. I don't know if you want to expand on this, but Chris Lippett wanted to know about the data visualization being accessible to the public and how that was done.
Sorry, just to clarify,
yeah.
I meant, like, is it currently visualized to the public in any way, and is it accessible?
Yeah,
outside of the exhibit?
Yes, there is a this is actually a museum for electronic art in Linz. This is also not only the Ars Electronica Festival, this is the festival for 1 week in September each year, but also they have a permanent exhibition there. And this deep space is part of this museum there. And we are at the moment also working with the with the colleagues there in order to make this a permanent part of the exhibition. So they have different types of also using laser scanning. For example, they have a very interesting project from a laser scanning project from the pyramids, from the Cheops pyramid. Here, actually, we also can go in there through the different chambers, and we also we just have the point cloud as it is now, with actually not that high resolution that we have it available here in the deep space. And there are also some new technologies in order to use the 360-degree images we also have from the total station, from the laser scanning available, also to integrate those here into the environment. So this is always a challenge of the amount of data in order to make it accessible. But this is a permanent exhibition where people actually can come throughout the year.
All right, we are right at our time, so I think we'll leave the questions there. And let me just say thanks again, Gernot, for a great presentation. Really appreciate you being with us today. And also just on behalf of the department, thanks for all the collaboration over the years. And it's been great to see the flow of students back and forth between the different universities. So I will let everybody know when the recording of this is available. If you want to share it with friends, it'll be up on the UNM Geography website probably by next Monday. All right. Thanks, everyone.
Okay. Thank you very much. Enjoy your spring break and take care. Thank you.
Thank you.
Thank you, Gernot.
Bye.
Thank you so much. Great.
Bye, everyone.
Thank you.